In this lesson, we are going to use ESP32 module from SunFounder's ESP32 Learning Kit to control an RGB LED from our mobile device. I type red, send, the LED is red, and when I send LED off, the LED is turned off. And this way you can touch the screen to select any previous color that you have done, easily execute turn off or select the color. Let's get started with this. ESP32 starter kit from SunFounder. This is the best ESP32 learning kit from SunFounder. It has this ESP32 microcontroller which has built-in Wi-Fi and Bluetooth. This board can do everything Arduino Uno can do or many other Arduinos can do, plus extra more features. Because we have Wi-Fi and Bluetooth, the possibilities are endless. You can get connected to the cloud or do the control or read information or values via your mobile device or your desktop or over the cloud from a far location. It comes with a camera extension kit where you can stream the video over Wi-Fi either through the cloud or to your network, and also it comes with micro SD card where you can save images on the micro SD card, or you can write from the device any information, log the information on the device and read it back. You can power the board using this included 18650 lithium battery, and it has built-in charger where you can connect micro USB and charge the battery. The kit comes with 320 pieces of component that you can learn tons of projects. For RGB LED, we have 3 LEDs in one, which I'm going to explain it one by one, and we are going to connect them. And to understand RGB LED, we first let's have a look at the LED. LED is light emitting diode. It has 2 pins. One pin is called anode, which is positive. The positive is always long, the anode pin, and then the other pin is called cathode, and it is short. Here is the symbol for the same LED. We have a triangle with a line, and most of the time they put 1 or 2 arrows here to show it is light. The anode is on the back side of this triangle, and the side that has line, it's called cathode. And to turn the LED on, we cannot connect it directly to the power. We have to put a resistor to reduce the amount of voltage that is coming. So we are using it as a voltage divider, right, like this. The resistor can be connected between anode and positive like this, and the cathode is going to the negative. And this is the actual shape. So this is 220 ohm resistor. You will connect it. This pin must be the anode pin, the long pin. So it has been cut and it is connected, so the LED will turn on. We can have the resistor on the other side. So the anode is connected directly to the positive and the resistor can be on the cathode, and the effect is the same. There is no difference. And here is the RGB LED. RGB LED, however, has 3 LEDs in one. So red, green, blue, RGB, RGB, they are connected like that. If the anodes are all connected together, it's called common anode, and we have 1 pin for the positive, and then we have separate pins for the cathode. So this is called common anode, or we can have it as like this, common cathode, which the common will be connected to the negative, and the anode are separate, so we can control each. RGB LED is sold like this with 4 pins, or as a surface mounted device like this. Sometimes you can see it as a module which all the resistors are already mounted, so you have all the 4 pins and you will just connect it. So we have common and then red, green, blue. For the common anode, the resistors are connected at the cathode because the anode is common, so we are connecting each resistor for each LED in this package. Or we can, if it is common cathode, then the cathode will be connected to the ground and the resistors will be connected to the anode of each resistor to divide the voltage and allow 2 volts for the LED. Here's the actual RGB, and here is the picture with a proper explanation from SunFounder. So if we divide it in 2 pin of the right, 2 pin on the left, the 2 pin on the left, the second one from the left is common, which is the longest one, and here we can see this is the longer pin, and that is our common. And then from the left we have red, green, blue, R, G, and B, and here this is our R, and then G, and then B. So you cannot make mistake. If you put it like this, then the long is on the right side, and that's incorrect. So we are going to use it like this. Now I'm on the Bing search engine. Just type RGB color picker with slider, and the first one that comes, click on it. To understand the color of RGB, we have to first know that all colors can be created, or any color can be created from combination of R, G, and B. This area shows the actual color that we have created, and because there is no color, the red is 0, the value is red is 0, green is 0, and blue is 0, so we see black color. Now if I move this, you see some red here, and this is maximum value. Why 255? Because it's 2 to the power 8. So we have 8-bit color resolution, which means from here to here we have 255 steps to add or adjust the color. Of course, there are higher bit rates that can be done. For our purpose, we are using 8 bits. So this is red. Now if I slide it back, the value, you just read it here, pay attention. And this is green, maximum green, light green, and then dark. And then this is blue. So we got these 3 colors. Now the value could be shown also in hex. Pay attention, this is the hex value, but those are RGB. But we are paying attention to this. Now let's have red and let's put green. So this is red, this is green, and if you combine it, you get yellow color. And if we have red and if you put blue, then we get pink color. So this is the combination of red and blue. Now I'm bringing that down. This is green now. Green is the maximum. Now if I bring red, you know it was yellow, but blue and green will create this sepia, this color. And if I bring all the colors, it will be white. This is interesting. If you combine the right proportion of R, G, and B, red, green, and blue, you will create a white color. And now if we pay attention, this is 255, 255, 255. Now this color is red is 0, and then we have green and blue, 255, 255. That's why we are getting. And if you want pink, so red is maximum 255, and then 255 is a blue. If we put them at the middle, you will create a darker pink, because we are moving these two together, 82, 82, or 83, so they will be the same. Now the fun starts when you play with these values and you create like different color. Orange, you see somewhere here, if we have full red and blue is 0, green is at the middle, that's you see we are creating orange. If I bring that here and this, we have different kind of blue. So we, with all this, we can create different color that we want. And We are going to practically test it and see it here. Come to this page, docs.sunfounders.com, scroll down until you see ESP32, then click on ESP32 Starter Kit Main. On the left side, click on Arduino User, and on the left side, scroll down up to 7.2 Bluetooth Control RGB LED. This is the documentation page for today's lesson. We need to have the previous lesson 7.1. You must watch it, otherwise you will not be able to understand it. We need ESP32 board, we need ESP32 extension board, breadboard, jumper wire, 220 ohm resistors, 3 of them, 1 RGB LED, and this is our RGB LED. This is the wiring, which I'm going to explain it. This is the code, which I'm going to explain it in the code section, and the rest is the setup of the application or app, which I'm going to explain it, and here there are the important parts for the code which have been explained. When you use ESP32 with SunFounder's ESP32 camera extension module like this, it comes also with a battery on the package, and it comes a built-in charger, so you can connect it and charge it and disconnect, and later on you can use it with a lot of power, so you can power up your application very easily. So get RGB LED such that the longer pin is the second pin, not like this. It's now the third from the left, so second pin from the left, and insert it on the breadboard somewhere on this side. Get 220 ohm resistors, 3 pieces, connect one to the left pin of this RGB LED on the same line, and connect it somewhere here just in front of it, or maybe a little to the left, doesn't matter. Get second 220 ohm resistor, leave one line because this was the common one, the longer pin, go to the next one and connect it somewhere here, and then get the third one connected to the last wire, to the last pin of RGB LED, and connect it like that. Now I have connected 3 wires here, 25, 26, 27, from the left, red, green and blue. So connected with this order and color, and we are connecting the red to the first resistor here, green to the second resistor, the same line anywhere, and then blue with the last one, because the last each is connected to one pin. And then I've connected one wire to the second pin, this is the ground, and connected to the common pin, which was the longer pin, somewhere here. The wiring is now completed. Now let's see how we can select the ESP32 board. We can click here under the select board and type here ESP32 DEV. As soon as you type dev, you will see dev board. You can select it and click OK. So the board has been selected. Now we have to select the port. The other way to select the board is click on Tools, Board, ESP32, and select the ESP32 dev module. Now we have to select the port. If I click here, it shows 2 ports, and I don't know which one belongs to my device. Sometimes you will not see the number properly. So the best way to be sure, right click on the Start menu, go to the Device Manager, and you will see here the ports. If I click on this arrow, it will show me the ports. One is USB serial CH340, the other is USB serial device. And here, now it's connected. If I disconnect this, one of them disappears. The one that disappeared is my board. So 6 stays and 8 disappeared. If I connect it, so 8 is my COM port, CH340. Now 8 is my COM port, and I can select it. Or I can click on Tool, Port, and here you will see it. You can select whichever you want. Ours is COM8. Now we have successfully selected the board and the port. And this is very important. It must be done first. I'm opening Arduino IDE. Let's open our project by clicking on File, Open. On the left side, click on Downloads. Then ESP32 Starter Kit Main on the right side. Double click to open it. Double click on C. Double click on Codes. Scroll down to 7.2. Bluetooth RGB LED. Double click to open it. Select the file. Click Open to open it. Here in the code, we are defining pin 27 as a red pin, a variable type integer and constant, and 26 for green, and 25 for blue pin. These are all constant, not changing. We're also defining channel 0, 1, and 2 for red, green, and blue respectively. And this is for the frequency of pulse width modulation. 8 is the resolution for the pulse width modulation. And this is our Bluetooth name when we search it on our device. We have explained this in a previous lesson. And the most important part for UUID, as I've explained it before, you can select from UUID generator website if you need it. And this is the code where inside this my characteristics callback, here the value that comes, this value, we are checking it if it says LED underscore off, or we should have just said it as off, then we set the color as 000, that LED will be turned off, and this will print this text on the screen. If the value is equal RED or red, and then we send RGB value, R is 255, so that will be pure red, and green and blue will be 0, so we get red color, and this will print it. Otherwise, for green also, red is 0, green is 255, and blue, because it's in order green, blue, red, green, blue, and this will print the text. The same way for the blue, only the last portion has 255. And if it's yellow, we will set this value for yellow, and purple. So these are just limited color, but you can define more color as you wish. First thing, let's go to the App Store or Play Store, type light blue and search, and you will see this icon, the first, and click or touch to the Get or Install button to install it. When the code is ready, just click to upload it. Just open the light blue app. Make sure the Bluetooth on your device is turned on. It will search for Bluetooth, and you will see ESP32 Bluetooth, which is this device. I'm selecting and to show up. If you don't see the device, just press this reset button and you will see ESP32. Just touch it. It's getting connected. Now we want to send a notification. The top one, as I mentioned before, is for notification to the device, and this is for sending. I'm touching the bottom one and selecting the hex, touching, and making sure that we can get the hex value, or hex is selected. Let's select this bottom one, so it's a string, and then touch write new value, and here everything is ready, and I'm typing red, R-E-D, wait for this LED, and I'm touching this button. This is red, and the serial monitor was not on. Let me click and open it. Make sure that the value that we set here in the setup, 115,200, this number must match, and then we will be able to see it Let's now type green, and send it. This is now green, and we can see the text green here on the serial monitor as well. And the same way, let's type yellow and send. Now it's yellow, and we read here as well the yellow. But if you type something like book, because this word is not associated to any color, nothing happens and it's not being displayed. Value for turn off, LED off, not turn off. So let's do it again. LED underscore and then off, and then send. LED is off, and we see the text. Perfect. Autocomplete, just remove the space, make sure there is no space, and send it. It's now purple and the text is printed. And whatever task that you have done are here. For example, if I want green, just touch it and green will be sent. If you want red, just touch it, it will be red. Turn it off, just touch like that, and this is how it works. Very easy.